Okay, here's another one to graph. It's still an exponential function because it's written in the form a times b to the x. So the value of a is 3 and the value of b is 1/2. So it is exponential. So also I want to point out that there's other ways to write this. You could write it as instead of the 1/2, you could think of that as to the power 2 to the power -1. So you could write it as 3 times 2 to the -1x. That means the same thing. And then you could also multiply exponents there to see this is the same as 3 times 2 to the -x is another way to write it. You could also just write it as a fraction, 3 times 1 over 2 to the x, or 3 over 2 to the x. So yeah, there's a lot of ways to write this, but these are all the same function. Anyways, I'm going to pause it here to do it. I'm going to recommend that you pause it here to at least copy down the question. And I recommend doing it too, because it actually plugging in the numbers, because it will help you understand it. And we're also going to try to answer this question. How does this graph compare to the graph from the previous video? How is it the same or different from the graph from the previous video of f of x equals just 2 to the power x? So I'm going to pause it here. Here's the results I got. This is some tricky arithmetic. You might need to plug it into your calculator to check if you're having trouble dealing with like the negative exponents combined with a fraction here and getting all that right. That is a little tricky. So yeah, you could also do it with a calculator, or you could also use one of these other versions of the thing to do it a different way if you need to. So let's plot these points. I've got -2, 12, which doesn't even fit. It's going to be off the top there somewhere. And then -1, 6 is right here. 0, 3 is here. 1, 3 over 2 is 1.5 is right there. We got 2, 3/4 right here. And 3 and 3/8, which is a little bit less than 1/2. So the graph is going to look like that. We also know about it that the bigger that x gets, the bigger the denominator will get here, and you'll get a number closer to 0. So for example, if I was going to plug in 4, then we'd be getting 3 over 2 to the power 4, which is 3 over 16, and that's going to give us another point closer to 0. So then the graph is going to have that -2, 12 point on it up there. And we know that it's just going to get closer to y equals 0 out there at that horizontal asymptote. Whoops. Okay, so it looks something like that. And how is this the same as or different as the graph from the previous video of f of x equals 2 to the power x? Let's look at your notes from there and see what that looks like. One of the things we said was that it had a horizontal asymptote at y equals 0. The x-axis is a horizontal asymptote. That is also true here. This is a horizontal asymptote at that line, the x-axis, where the y-coordinate is always 0. So that's one thing they both have in common. Another thing they both have in common is the other property that we mentioned in that previous video was the y-intercept is 0a. In this previous one, the intercept was that 0.01 because the value of a here is 1, if you write it as 1 times 2 to the x. In this one, the value of a is 3, and we still have that point there. So we can say that both have y-intercept 0a. What's different about them is that this graph is decreasing. When you have a fraction in the exponent, then making x get bigger, so as you go from left to right here, as your x gets bigger, then the result gets smaller because it's like you're multiplying by more factors of 1/2. So this is a decreasing graph, but let's look at the other one. With this one, when it was y equals 2 to the power x, as your x increases here, then your y coordinates are also increasing. So this gives you an increasing graph. Here is a reading question for you to do. These are just true or false questions. I'm not going to give you the answers, but I'll give you a big hint, which is that you can pretty much find all of these answers somewhere in your video notes if you took good notes. Or you might need to go through and think about them a little bit too. But good luck with that. And there's going to be one more video, I think, and then I'll see you in class.